Hello. Throughout my career, I have worked in building software solutions for the medical space. Building these solutions at a POC quality level usually takes several months, and a lot more when you're building an enterprise quality software. But with today's technology, especially the use of large language models and modern SDK libraries like the Google ADK, we can build intelligent solutions in, in a fraction of the time. In addition, by using an AI project assistance like Google Antigravity, we can take the development effort to the next level. By using a specification-driven approach, we can iterate and feed the information to the project assistance to quickly transition from a prototype into a production-grade application. Hi, my name is Oscar, and today I want to show you and talk about this application that is an AI agent-driven application. It's a hard disease risk assessment agent. The application basically evaluates a hard risk um, profile for people by combining the use of AI. So basically, we have an AI front end that conducts the interview and it collects the person's profile information with social habits in addition to demographics and so on. It also uses a server proxy to be able to handle the front end requests with a server side agent that actually uses a model context protocol tool. And the purpose of this tool, this is a custom tool that hosts a machine language model that actually does the risk assessment and evaluation and returns basic scores for the evaluation. We then use an agent that actually uses a large language model like Gemini to be able to read this score and create a clinical profile for that patient. Keep in mind that this is just for illustration purposes and it's really not a medical guideline or certified clinical profile. But the question is, how do we build this? Well, what does it take to build this? So let me go ahead and show you basically our solution. Okay, so right now what you see is the application. The application is hosted on Google Cloud, Cloud Runner application, and we actually have security. I won't show you the login profile as that's it takes some time, but it does have it has a level of security to enable you to log in and have access to it. This application takes into account several usability requirements like multi-model accessibility, and also is very secure using SSLs and also Google authentication process, right? If you can actually toggle the UI, and if you want a live version of it, you can just toggle that and you get that. But the point here is to try to make this assessment very smart and very easy to use. Instead of having a chat-driven type application, we actually create UI components that make it much easier for the person to be able to respond to this interview. And we also have the hotkeys, we have clicks, we support basic clicks and also voice input. Voice input basically enables us to just click and enable and allow the access to the microphone so the person can talk to the agent and be able to fill out the information. But the agent basically here is just collecting demographic information. And basically we can just select our criteria and just continue the process as we go. So here we collect basically information like BMI, or we can calculate the BMI based on height and weight, and also lifestyle factors that are very important. So here we just basically need to understand what some of that criteria that is required for us to be able to conduct this process, right? So as we go and basically fill out the information, and I won't show you some of those, but this is basically some of the medical history information that gets collected. But I'll just quickly navigate through all of them and just basically to create a profile. And the goal here is to be able to get to the point where we're ready for the analysis. So here we just basically kind of review what's being provided to the agent, and we can actually just either say if we enable voice or click and submit the profile. So what's going to happen now as we submit the profile, we're actually calling, the agent is calling an NCP tool to be able to do the risk assessment evaluation. As it's processing, we also provide some help tips for the individuals, right? So what the agent is going to do now, as it gets the score, it's going to get the score from the machine language model. It's going to be able to use a large language model to be able to give you a clinical assessment of what's happening. So here, basically, we're saying that there is no risk, and the probability score is very low. It's 4.9%. And then what you have is a clinical analysis using Gemini, and it just tells you basically your category, some of the pointers that some of the information that we gave the agent to be able to evaluate it. But the server-side agent is able to read all this and basically give us this information. But how do we build this, right? It seems very complex, and how long does it take? Yeah, back then, this usually took a long time, right? And the probability score was not as accurate as it is now with machine language models and basically all the AI technology around it. But what you want to do is you want to visit my GitHub repo, AI engineering, and you want to go to the Vive coding folder right here. Right, and here I also have other projects that you can look at, but specifically for this, you want to look at the Vive coding folder and read and take a look at the README file. In the README file, I break down everything. The purpose of this, why I chose to create this project, what does it solve, right? And basically what it's solving is helping, right? It's helping evaluate risks. It's creating a risk assessment evaluation, basically based on personal profile. It just basically also show us that we took that the approach to build this is we use by coding, basically by providing by following a specification-driven approach where we actually build all the specifications. As you can see here, we have a collection of specifications for two main areas. We have the app and we have the API. And we can see all the specification documents with their respective responsibilities and area of coverage. We also build and automate the deployments, right? So this is deployed on Google Cloud. And you can see the architecture is the client-side agent, the server proxy to manage the authorization, the server-side agent to orchestrate the NCP tool, clinical analysis, and the NCP tool and machine language model. And I gave you a whole breakdown of the project, how it's broken down, how we're using Docker files for deploying the application, how are we using serverless technologies for everything that we deploy. So we try to manage the cost of the application very down. So, but to build all of this, I mean, is really an enterprise quality project that we're able to build with the power of AI a lot, and by following our specification, which is the key of all this, right? And using a Google ADK as well. And also I cover cloud infrastructure, show you all the components like Cloud Runner, Cloud Functions, Vertex AI, IAM for identity management, IIP for the security of the front end, and so on. So building this type of solution is pretty extensive, right? You can take a look at all the folders where you see the API and the apps, right? And you can see the some of the bash scripts that are done to be able to build the solution. This has a lot of coverage and a lot of activities. It usually takes multiple teams to build, but with the power of AI these days, we're able to basically build this in a fraction of the time. What I gather from this experience of using specification-driven approach has always been established before, right? But now is by building our specification and detailing all the information, we can pair ourselves with a AI assistant, and we can build this a lot faster. a lot faster, because essentially our specifications are the prompts, the system prompts and the user prompts that we can feed to the AI to be able to build. And one of the things I have noticed here is that we got to be very careful defining our requirements and governance and so on, because the AI is gonna go a little bit off the rails and it's gonna try to build something that may not be useful. But you iterate through it as you build the specifications, you refine them, you polish them, you discover new things, then you keep building that out, and then you just go back to Antigravity and you basically tell them, hey, I updated this specification. Please review it. Please tell me if you see any gaps and tell me what action you're going to take. And Antigravity will give me feedback on everything that it's doing. If it identifies a gap, it will do it. If it doesn't, then I can authorize it to continue. Or the things that I notice is that Antigravity may give you something that's outdated. So what I do is, in addition to feeding the specifications, I feed some references, right? So I say, look at the documentation for the SDK, for the latest versions, we can do this. Look at the Google Cloud CLI documentation, and we can also get updated, and we can do new stuff to be able to build and basically deliver the task that we're trying to build. So in all, it has been a great adventure, and the power of AI is really taking us to the next level. Please start the repo if you like it. Please follow it, follow the YouTube channel, please. And thank you again. My name is Oscar, and it was great to talk to you again. You take care. Bye-bye.